Welcome to Exam Sale. In this video we walk through the syllabus for the BICSI Registered Communications Distribution Designer, or RCDD, so you know exactly what to study and why. The RCDD exam covers 14 domains with precise weights, 5 core areas at 10% each, bonding and grounding at 8%, outside plant at 7%, fire stopping and power distribution at 6% each, principles of transmission, electromagnetic compatibility, and telecommunications administration at 5% each, and structured cabling systems and field testing at 4% each. Each domain lists key topics, difficulty, and estimated study hours so you can prioritize. Overall focus ranges from media selection and space design to testing, grounding, and special environments. Its cables and connecting hardware is weighted at 10% and marked medium difficulty with about 25 study hours. You will learn to select and specify copper, optical fiber, and coaxial media for high-performance distribution. Expect to master balanced twisted pair performance categories, connector and termination hardware like 8P8C, shielding choices, and copper distance limits. The fiber portion covers single-mode and multimode classifications, connector types, splice management, PON components, polarity, and strand count calculations. Telecommunications spaces is 10%, medium difficulty, and about 20 hours of study. This domain teaches design and layout of entrance facilities, equipment rooms, telecommunications rooms, and enclosures. You will learn sizing, environmental controls, clearance and accessibility, and floor and ceiling requirements that affect equipment placement. Racks and cabinets topics cover RU calculations, cable management, thermal strategies, seismic bracing, and secure anchoring of hardware. Backbone distribution systems carries 10% weight, medium difficulty, and roughly 22 hours of study. You will design hierarchical star topology backbones that connect spaces within and between buildings and choose appropriate media for backbone segments. Focus includes distance limitations, redundancy and path diversity, interbuilding and intrabuilding segments, and pathway solutions such as conduit and interduct with pull box sizing. Service provider demarcation points and backbone support considerations are also covered. Horizontal distribution systems is 10%, medium difficulty, and estimated at 20 hours. This domain covers pathways and media from the telecommunications room to the work area outlets, including conduit, trays, J-hooks, underfloor duct, and plenum concerns. You will learn pathway fill calculations, support intervals, outlet density and placement, consolidation point rules, and furniture system integration. Practical design examples show how to balance pathway capacity with work area requirements. Special design considerations is 10%, labeled hard, and requires about 30 hours of study. This domain addresses specialized environments such as data centers, healthcare, and wireless systems where standard solutions need adaptation. Expect to study data center topologies, hot and cold aisle containment, cooling and cabling approaches, reliability tiering, and SAN cabling. Wireless topics include access point placement, DAS fundamentals, IBS integration, PO design for building automation, and security system cabling. Bonding and grounding is 8%, hard difficulty, and about 18 hours of study. You will learn to design systems that protect people and equipment, including primary and secondary bonding busbars and telecommunications bonding conductors. The syllabus covers conductor sizing and labeling, equipment bonding procedures, rack bonding, lightning and surge protection, and grounding electrode connections. Practical grounding details are emphasized for both shielded cabling and non-conductive pathways. Outside plant is 7%, hard, and estimated at 20 study hours. This domain focuses on campus and interbuilding infrastructure and best practices for long runs outside buildings. Topics include underground duct bank design, direct buried cable protections, aerial pathway design with poles and anchors, right-of-way and permitting, utility separation, and suitable cable jacket materials. You will learn how pathway design and environmental forces affect material selection and maintenance. Fire stopping is 6%, easy difficulty, and about 12 hours of study. You will master restoring fire ratings after pathways are installed by learning through penetration and membrane penetration concepts. The curriculum covers mechanical and non-mechanical fire stop systems, T, L, and W ratings, reenterable solutions for cable pathways, and required documentation for qualified systems. Practical examples show how to select and document compliant firestop assemblies. Power distribution is 6%, medium difficulty, and estimated at 15 hours of study. This domain teaches calculation and planning for AC and DC power in telecommunications spaces, including UPS sizing and redundant A and B feed design. You will learn PDU and branch circuit design, voltage drop for DC systems, power quality concerns, harmonic mitigation, and protection strategies. Case scenarios demonstrate how to size and distribute power for reliability and safety. Principles of transmission is 5%, medium difficulty, and about 10 hours of study. This theoretical foundation covers decibel calculations, attenuation and insertion loss, crosstalk parameters like next and fexed, and return loss and impedance mismatch. You will also study signal-to-noise ratio concepts and optical fiber dispersion and modal bandwidth. These fundamentals help you specify links and interpret test results for reliable performance. Electromagnetic compatibility is 5%, medium difficulty, and roughly 10 study hours. This domain focuses on managing interference and ensuring systems coexist without disruption. You will learn about EMI sources, separation distances between power and data cables, shielding effectiveness, RFI mitigation, transient voltage strategies, and pathway selection to reduce noise. Practical mitigation examples show how design choices affect electromagnetic performance. Telecommunications administration is 5%, easy difficulty, and estimated at 8 hours of study. This domain covers documentation and labeling practices needed to manage an installed infrastructure. You will learn administration classes, identifiers for spaces and cables, durable labeling standards, record keeping and database management, color coding, and standardized drawing symbols. Clear administration practices ensure maintainability and reduce risk during changes. Structured cabling systems is 4%, easy difficulty, and about 10 hours of study. You will understand industry standards and the processes that govern cabling design, including ANSI-TIA and ISO-IEC hierarchies and the difference between codes and standards. The syllabus includes RFP development, construction document sets, and standardization of design deliverables. Learning these topics prepares you to create compliant drawings and specifications. Field testing is 4%, medium difficulty, and estimated at 12 study hours. This domain verifies and certifies installed cabling to ensure it meets design specifications through procedures for copper certification and optical fiber Tier 1 and Tier 2 testing. You will learn test equipment calibration, troubleshooting failed links, LSPM and OTDR methods, and how to document and review test results. Hands-on understanding of testing protocols is essential for acceptance and quality assurance. That completes the syllabus walkthrough for the RCDD exam. Use the domain weights and estimated study hours to plan focused study sessions, and concentrate on hands-on skills for grounding, testing, and special designs. Good luck, and study smart with Exam Sale.